Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the cross product of the two vectors. So here, if you have a two vector A and B, so perpendicular to this A and B, that is your cross product. So if you are going up, so it is A cross B. If you are going down, this is a B cross A. So this is the plan actually you will have. So this is a B vector, this is a vector, and the perpendicular to A and B, which is your the cross product. So if you take the length of the AB, so this is the length you will get it. This is the length of the cross product, and the angle formed between the theta is the angle between the A and B. So before taking the cross product, we have to know how to evaluate the determinant. So this is a 2 cross 2 determinant. So here it is very easy. You have to take cross multiply AD minus BC. So this is the expansion of the 2 cross 2 determinant. Now if you have a 3 cross 3 determinant, so how will you evaluate? Because this one, the determinant is very important in the cross product. So if you expand this one, you will have A1. Leave the row and column. If you choose A, so you have to leave the row and column of this term. So you will get only this part, only this one. So if you cross multiply, what will get? So this is B2C3 minus B3C2. This is done. Finish. Complete. Now the next one, I will take the next minus, alternate plus or minus, minus A2. So leave the row and column of this part. So you will get only these four elements. So this one, two, three, and four. So if you cross multiply this part, you will get B1C3 minus B3C1. This is done. Now what is the last part? The last part is A3, which is the plus. So alternate plus or minus, because we start with the plus, the next one is the minus, the third one will be the plus. A3. Then what are the remaining part you have? You have this part, these four parts. So what you'll have? B1C2 minus B2C1. So this is the expansion of the determinant of 3 cross 3. Now here we will have a cross product. How will you take the cross product of two vectors? So as we already know, this is the A1I, A2J, this is A3K. And similarly, this is the B vector B1I, B2J, B3K. So this is the IJK are the unit vector along X, Y, Z respectively. Now the vector A cross B, you can write it this one as I, J, K. So this is the vector form. Now when you take this one, the first one A, so therefore the component of A vector A1, A2, A3. Then the component of B vector B1, B2 and B3. So this is how we will evaluate the cross product. So how will you evaluate? This is I vector into cross multiply. It is A2 B3 minus A3 B2 minus J vector. Then here you have leave this row and column. So you will get A1 B3 minus B2, that is A3 B1. So since it is a product, you can write it here in the order, no change since it's a product. So K vector. So leave the row and column, you will have A1 B2 minus A2 B1. So this is how will you evaluate the integral. And very important thing here, when you evaluate the cross product, this will be a vector form because you will have I, J, K. Whereas in the dot product, if you take the dot product, so the output will be the scalar. Whereas in the cross product, the output will be the vector form. So this is the example which is given here. So we will solve this problem here one by one. So this is a one example we will give taken here, the A vector and B vector, and I want to calculate the cross product of this one. So as we know this part, This is I, J, K. So I write it A cross B. So which is equal I, J, K. This is the vector, the first row of the determinant. The next one, fill the component of A. What is the component of A? This is 1, 3, 4. The A vector. The order should not be changed. If you change the order, the negative will be there. So we will discuss about that one in the property. So the first A component, the next one B component, 2, 7 and -5. Now you have to evaluate this determinant. So if you evaluate this part, you will get it is -15, -28. This is done. I is finished. Next, minus J. Leave the row and column 1 into -5, -5. Minus 2 into 4, which is 8. Plus J is also done. Now what about the K value? The K value is leave the row and column 1 into 7, 7 minus 2 into 3, 6. So therefore the value will be here -43I. Then minus 13 minus into minus plus 13. It is plus 13J. Next plus K. So which is a vector. Which is a vector form. Now I have to prove this one. The A cross A should be equal 0. So how will you prove this one? This is very simple. I will take the A vector as what? A1, the general vector A2, A3. And I want to take the cross product of the same vector. So let us check what happened. So I, J, K. And here we will have the component of A1, A2, A3. Same component because we will have a same vector. Now, if you expand this determinant, you will get A2, A3 minus A2, A3 minus J into A1, B, A3, A1, A3. Next, plus K into, this is A1, A2 minus A1, A2. So, if you go through this part, you will get here, this is 0, this is 0, this is 0. So you will get a 0I, 0J, 0K, which is a 0 vector. 0 vector. That's it. Now here, this is a very interesting thing here. I have to show there is no vector is given. We have to show whether it is a meaningful or meaningless. Is it valid or not? Whether it is a vector or a scalar. So very important thing we will take here. This one is A, B, C is a vector first. I will tell you here. This is A, B, C are three vectors. Now, if you take a cross product, you will get a vector. Vector dot product vector, you will get a scalar. A scalar. Now, this is a vector when you take a cross product. This is already A is a vector. If you take a cross product of these two, you will get a vector. This is a vector. This is a very important thing here. Dot product, always you will take the scalar. Here the cross product of two vectors, which is a vector. The scalar and vector. Now, let us take the next one. Here you will get this is your scalar and this is also a scalar. And if you have a two scalar, we cannot take the cross product, which is a meaningless. This is not possible, which is meaningless. Meaningless because when you take a cross product, it should have the vector form. Both these one should be a vector, so it is a meaningless. Now let us go with this one here. When you take a cross product, the dot product of BC, you will get a scalar. This is a scalar. So scalar and vector, you cannot take the cross product, which is also meaningless. And here, when you take a dot product, it's a scalar. When you take a dot product with this one, with the vector, the dot product you can take. So here, if you will get the dot product, some scalar value, and you will multiply that one with the scalar. So which is the meaningless here? The scalar vector multiply by the scalar. So I multiply that number with the scalar. So you will get a vector form. If you see the example, suppose if you will get a dot product of BC, you will get suppose something 4. I can multiply that scalar with the vector. So the final output will be the vector. So therefore it is a vector. Now the next one here, this is a vector, this is a vector. When you take a dot product, it becomes a scalar. So this is how you will validate the test. So this is a very important thing. So two things we will have a meaningless quantity. So there is no vector are given, we will take that one. Now see here this one, when you take the dot product is equal 0, we will say it is perpendicular. But here when the cross product is equal 0, it is a parallel. So this is the parallel when you will have a dot, the cross product is 0. So when we say this cross product is orthogonal to A and B, what do you have to prove? The dot product must be equal to 0. So that's why we will take it here. The A cross B dot A is equal 0. A cross B dot B equal 0. If it is orthogonal to the A and B, it must satisfy these two conditions. Okay. Now here we will have the vector, the theta value. If you want to calculate the magnitude of the A and B, how will you calculate the length of A, length of B, and the sine theta? The theta will be lies from 0 to pi. And this is the very important thing, the dot product is equal to 1. So I dot I equal 1, I dot J dot J equal 1, K dot K equal 1. But here I dot J is equal K. J dot K, which is where cross, it is I cross J, which is K. J cross K, which is I. So here if you change the property, so this is the properties we'll have. So this is not a commutative. If you take the reverse order, you will get a negative part. Negative will be the sign. If you take a multiply with the scalar, so you will multiply the C, A cross B, and A cross C, B. Now similarly, this is the cross product with the associative law, and here we will have a cross product the C vector on the last. So these are the properties what we have taken here. Now very important thing here, the area of the vertices PQR. If you have a 3 vertices, how will you calculate the area between this one? This is a P, this is Q, and this is R. So how will you calculate? So half into the cross product, the length of this and length of this. So I have to take the length cross product of this length into half. Now this is the example 3. We will have here, find the vector perpendicular to the plane PQR. So I have to calculate the PQR. This is the points are given. I have to form the vector first. So what are the vector here? What is the vector? PQ over PR. So I have to calculate the PQ and PR. So what is PQ? PQ is a vector, so I will subtract this part to make a vector -2, -1, -3, 5 minus 4, which is 1, then -1, -6, which is -7. So this is the PQ vector. And similarly PR vector. What is the PR vector? So subtract with the R with the P. So 1 minus 1, it is 0. Then -1, -4, -5. 1 minus 6, which is equal again -5. So this is the PR vector. I have to take a cross product of this vector. So what is the cross product of this? PQ cross PR, IJK. Then we'll have the component of PQ -3, 1, 7. minus 7, 0 minus 5 minus 5. Now which is equal I vector into minus 5 minus 35. J vector into 15 minus 0 plus K vector into 15 minus 0. 15 minus 0. So therefore the answer will be minus 40I minus 15J plus 15K. So this is the vector. Find a vector perpendicular. This is the vector which is perpendicular to the points, this point. And any vector which is the simplified part of this one, which is also a scalar multiply. This is a scalar multiply is also perpendicular to this vector. Let us take, this is a vector, we will get 40 comma minus 15 comma 5, 15. So if you divide it by 5, 5 is a common factor in all, therefore it is minus 8 comma minus 3 and 3. So any vector multiple of this one, it is perpendicular to the points, perpendicular to the points. Now let us solve the next one here. Find the area of the triangle. Find the area of the triangle with the vertices. So this is the vertices is given. What are the vertices here given? So PQR, I have to form the vector first. So I will calculate PQ, form the vector, and PR. So after that we will use this rule. After that we will use this rule to calculate. So what is PQ? So PQ minus 2 minus 1 minus 3. Then we will have the next one 5 minus 4 which is equal 1. Then minus 1 minus 6, it is minus 7. The next one PR. So 1 minus 1 0 minus 1 minus 4 minus 5 1 minus 6 which is equal minus 5 again. So this is going to be a same vector what we have seen in our last problem. PR cross PQ cross PR. So I will calculate the first vector, then take the length, magnitude, then divide it by 2. For that one, we need our the cross product. What is the cross product here? 1 minus 7, then 0, 5 minus 5 minus 5. Now if you evaluate this integral, the determinant, minus 5 minus 35 minus j times of 15 minus 0 plus k times of and then 15 minus 0. So if you simplify, you will get minus 40i minus 15j plus 15k. That's it. And then I have to start the taking the magnitude. So what is the magnitude here? Square root of 1600 plus 15 square 225, again 15 square 225. Now the final answer will be, if you write it in the answer, you will get 5 root 82. So area formula. What is the area formula? Area of triangle is given by half into PQ cross PR, the magnitude of this one. So you will get here 1 over 2 times of 5 root 82. So this is the final answer. Now the next one is a triple product. So you will have a 3 component. We have a cross product as well as the dot product. So here you will have a cross product which is a vector cross product. Here you will have a dot product. So this is the dot product. So both it is combined together. We say here this one is the box ABC. This is the box ABC cross product. And here it is dot product. So how will you form this one? This is actually determinant. I have to write it the determinant. The component of A. What is the component of A? A1, A2, A3. and component of B, B1, B2, B3. Component of C, C1, C2, C3. This is as usual 3 cross 3 determinant. How will you expand the 3 cross 3 determinant? The same formula we are going to use it here. So this is a geometrical representation of the scalar triple product. So here, what is the output you will get? What is the output you will get? See here, this one is a vector. When you take a cross product, this is a vector. When you take the dot product of this one, the final output will be a scalar quantity. It is a scalar quantity. So the volume of parallelepiped, we can take it as the magnitude of the vector product, the scalar triple product. So here we will have one thing, which is if A dot B cross C is equal 0, we say here it is coplanar. What do you mean by coplanar? All vector lies in the same plane. So coplanar is all the vectors lies in same plane. So then we call it that one as the coplanar. So this is one is a commutative property we will have. So you can calculate this same thing as a cross product with the dot product. So we will have to show that here, use the scalar triple product to show that the vector A, B, C are coplanar. So I have to find it here. If you solve this problem, you can answer both the answers. So you can know how to evaluate the scalar triple product. Also, what is the coplanar? So here A dot B cross C. So this is the scalar triple product. Now what is A value? The A component. This is all our vectors. So 1, 4, minus 7. This is B component. 2 minus 1, 4. Then 0, 9 with the negative sign and 18. So now evaluate this part. So if you evaluate this one, so it is 1. Leave the row and column, minus 18. Minus in the formula, you will have one more minus that becomes plus 36. Next, minus 4 times of, minus 4 times of, what is the next one? 2 into 18, 36, minus 4 into 0, 0. 4 into 0, 0. Minus 7, then you have minus 18, minus 0. So r plus 0 you will have. So what is the answer here? So this one, it is equals plus 18 minus 144, and minus of minus it become plus 4 8 18 into 7, which is equal 124. So if you simplify, you will get 144 minus 144. Answer will be 0. So we have converted this one. So the final output is a scalar. Is it right? So this is not a vector. So which is a scalar. And also we have find that one A dot B cross C is equal 0. We say it is a coplanar. Coplanar means all the all the vectors we will have on the same plane. This is what we will have. Now the last part of this topic, which is the application of the torque. So torque is nothing but the work done by the circular motion. So this is the torque. So torque is equal to the radius into the force. So what is the radius and what is your force acting on that one? So when you have take the length, the absolute value, so therefore you will get the cross product. So this is the cross product of the vector. So this is the formula we are going to use. Now first of all, we have to find it what are the things which is given in your question. So the question in the given, it is force is given, force which is acting 40 Newton force, and then this is the radius of the wrench, so which is the r is 0.25. This is the graph, the figure which is given. So 0.25 meter wrench is acting with the force 40 newtons. So the angle with the angle is given by the 75 degree. From the graph we can find it. So this is the angle which is 75 degree. Now I will use this torque. Torque is given by the R cross F. So in place of R, I can use the R, F, the magnitude of F, and sine theta. So just substitute the value 0.25, which is given here, and the force is 40 newtons and sine 75 degree. Now after that, if you multiply, you will get it 10 into sine 75. So use the calculator and get the answer 9.66 newtons per meter, or joule we can say. So using the calculator you can find it the value, and very important thing, the calculator should be in the radian, the degree mode. It should be in the degree mode because the given theta is in the degree mode. Thank you.